give you that. But what lines met in the middle?
Perpendicular.
There you go, the perpendicular bisectors. Okay, so big circumcenter, you've got perpendicular bisectors, okay, and equidistant from the vertex. Right? When we talk in-center, okay, my in-center were my angle bisectors, equidistant from the sides. Alright, so now we are talking medians. Okay, and medians is the segment that joins a midpoint. Oh, sorry. So it goes from the vertex to the midpoint of the opposite side. Okay, so it's gonna cut your opposite side into what? 2 equal parts. Okay? The difference between the median and the perpendicular bisector is what? There's a difference.
The perpendicular bisector is 2 equal parts.
Well, so is the median.
Oh.
There you go. Okay, the difference between the two is one of them, the median doesn't necessarily make a right angle. Okay, so if you don't know that that's a right angle, or you don't know that it is the circumcenter, okay, then you don't necessarily have a right angle. You just have 2 equal sides. Okay? Alright, so where these intersect, so the 3 medians intersecting is called the centroid. So now we have the circumcenter, the in-center, and now we've got the centroid. Okay? So my medians in this picture are who? Okay, remember it goes from the vertex to the midpoint of the opposite side. B, not P, B, F would be 1. What else? Okay, CD, I'm going to go CD just because we went vertex to the midpoint on the last one. And my last one that goes vertex to the midpoint? AE, good. In this picture, my centroid is the what point? P is my centroid. All right. A few special properties of this. Okay, and I'm going to use this line right here. Okay, that tells us our properties. AP is going to be twice as long as PE. Okay, and if I flip that around, PE is going to be half as long as AP. Okay, I can also tell you that AP, so the longer of the 2 parts, is going to be 2/3 of the whole thing of AE. I can tell you that PE, so the shorter of the 2 that get split, is going to be 1/3 of the whole thing. Okay, make a little more sense when we start going through it. All right, so it tells us JK is 22. So this whole thing is 22. It tells us that KN is 13, and it tells us OL is 18. What do I know about M, O, and N? They are well, the LM would be the median. Okay, I'll give you that. What does it do to the sides? Bisect them, yeah. Because M, so M is my midpoint, so those are going to be congruent. O is my midpoint, so those two are going to be congruent. is my midpoint. So those three are, or those two are going to be congruent. Okay, so if JK is 22, what's KM? 11. If KN is 13, what's NL? 13. And if they're both 13, what's KL? 26. Alright, if OL's 18, what's JL? 18, and if they're both 18, what's JL? 36. Not for that, right? Alright, so now I've got TZ is 60. I've got XZ is 28. And I've got WZ is 25. Alright, so this goes back to this guy right here. Okay, so if, what do I need? ZV is this guy right here, right? So if XZ is 28, ZV is going to be how much of it? Twice as much, so that puts us at 56. Okay, ZY is this guy right here, so ZY is going to be how much of TZ? Half of it, so that's 30.
Wait, when you get 30?
No, it's going to be a third of the whole thing. It's going to be half of the big one, okay? ZU, and WZ is 25, what's ZU? 50, yep, because we're going to double the little one. Alright, so that makes TY what? 90, good. And it makes XV 84. 28 plus 56, yep. Good call. So far so good, right? Alright. So now I have AG is 8. GF is 7. DG is 5. Okay, so GD has to be 4. So it's going to be half of that guy. It makes AD 12. Okay, so let's look at that. The whole thing is 12. What's 2/3 of 12? 8. What's 1/3 of 12? 4. Okay, see how that works? Okay, so CG is going to be 14. GF, oh no, that's why I was confused. GE is 10, BE is 15. So if we're looking at this whole line right here, okay, the whole thing was 15. What's 2/3 of 15? 10. What's 1/3 of 15? 5. Okay? So over here, it gives us TU, the whole thing, is 27. How do I have to find TX? Times it by 2/3. Yep. So to find TX, I'm taking 27 times 2/3. So what is 2/3 of 27? 18. TX is going to be 18. That automatically makes XU what? 9. Okay, so, and then it tells us SW. So this whole thing is 18, right? So to find SX, I have to take 18 times 2/3 is 12. Okay, so that makes XW 6. It's going to be half of that. that, yep. So 14. We do one more like that? I think we need to. Alright, so it tells us DH is 51. To find DJ, I have to do what? 51 times 2/3. 34. Okay, so that makes JH 17, yep. Okay, and you know you got it right if I take these two, have to add up to 51. Now they have to add up to the whole thing. Right, it says GF, the whole thing, is 60. Now, does it want the big part or the little part? The little part. So to find that, I'm taking 60 times 1/3. So what's a third of 60? 20. So that makes JF 40. That's double it, yep. Okay, and then JI, so it tells us, where am I? EI is 57. JI is the big part or the little part? Oh, but it wants EJ. Sorry, my bad. EJ is the big part or the little part? Big part. So I'm taking 57 times 2/3. What is it? 38? Which makes JI 19. Is 19 plus 38 give me my 57? Horrible? Alright, one other thing we need to talk about is altitude. Okay? The nice thing about when I'm talking about altitudes is it doesn't really have anything special to do with it. Okay? But an altitude joins a vertex to the opposite side so that it is perpendicular to that side. So now I have perpendicular, but what's the difference between an altitude and a perpendicular bisector? Well, this one's perpendicular. Well, that's what perpendicular means. Yeah, it's not a bisector. Okay, so it's not going to cut the opposite side in half. Okay, so the difference between an altitude and a perpendicular bisector is that it doesn't bisect it. Okay, and there can be different types of altitudes. This altitude is going to come down and be on the inside of the triangle. Okay, I might have an altitude that's on the outside of the triangle. Okay, and sometimes the altitude is an actual side of the triangle. Okay, the only thing that makes it an altitude is that it goes from a vertex and creates a right angle. Alright, now my altitudes are going to meet the three altitudes meet to be an orthocenter. Okay, what are my altitudes in this? Vertex makes a right angle. BF. Well, vertex, so my vertex is, so it'd be CD, if I'm going vertex to the right angle. And what's my other vertex? A goes to E, and in this point, my orthocenter is P again. I think all of our centers have been P's. Okay, nothing special about these, okay, other than they intersect in the orthocenter. Okay, so let's talk about this. Talk about all of our different centers. The circumcenter was created by the There you go, perpendicular bisectors. What created my in-center? Angle bisectors, good. What creates my centroid? Medians. And what creates my orthocenter? Altitudes, there you go. Okay, and then a few of the special properties. What's equidistant from the vertices? What was that? The circumcenter, yep. The circumcenter is equidistant from the vertices. The what is equidistant from the sides? The in-center is equidistant from the sides. I would know those properties. Okay, and then let's look at some centers. Okay, we got to name that center. What do I have here? If my angles are congruent, I have the angle bisectors, and angle bisectors intersect to form the in-center. In number 2, now here's the deal. We've got 90-degree angles, but I've got 2 that create 90-degree angles. I have altitudes that create 90-degree angles, and I have perpendicular bisectors that create 90-degree angles. Which one do I have right now? Altitudes or perpendicular bisectors? Altitudes, because I don't know if these split them in half. So I have altitudes, and if I have altitudes, I have the orthocenter. Yep, you might have to actually flip the page and look at it. Okay, and number 3 could be 2 different ones. It could be either perpendicular bisector or it could be medians, right? Which one is it, number 3? Yeah, it's medians, because I don't know if it creates a 90-degree angle or not. So my medians meet to make centroid. There you go. Four, what do I have? I have the circumcenter. Yep, I have perpendicular bisectors. Okay, number 5 tells me that those are equidistant from the what? From the vertices. What's equidistant from the vertices? Circumcenter.
It can't be an orthocenter?
No, we don't know if the orthocenter doesn't have anything to do with being equidistant from the.
Oh.
No. Okay, the only thing that's equidistant from the vertices is the circumcenter. What do we have at number 6? The centroid. Why? Because I have. Who am I talking about? What kinds of lines? Medians. Yep, good. Number 7? Orthocenter, yep. Because all I know is I have 90-degree angles, so I have altitudes. Not necessarily. Oh, actually, time out. I'm looking at this wrong. When it's drawn like this, they're supposed to say that those are congruent. So if those are congruent, what do I have? What's equidistant from the sides? Huh? In center. The in center is what is okay, number 8 I have orthocenter because those lines are altitudes. There you go. Number 9 I have in center because they are angle bisectors. There you go. And number 10 we have circumcenter because they are perpendicular bisectors.